During the Threads and Concurrency lecture, recall that we had a quiz in which we were comparing the boss worker model with the pipeline model. And we did that specifically in one example for 6 worker threads in both cases, and for a toy order that consisted of 11 toys. For the boss worker model, we said that it takes 120 milliseconds for a worker to process a toy order. And then for the pipeline model, we said that it takes 20 milliseconds to complete each of the pipeline stages, and a full toy order had 6 pipeline stages. Let's compare these 2 models to see which one is better. The computation that we performed during that homework showed us that regarding execution time, the boss worker models took 360 milliseconds for the 11 toy orders, and the pipeline model took 320 milliseconds for the same 11 toy orders. Now let's consider something else. Now let's compare these 2 models with respect to the average time they take to complete an order. To find the average time, we have to sum up the times that it took to complete every single one of the 11 orders and then divide by 11. The first 5 orders took 120 milliseconds to complete. They were executed by the first group of 5 threads. The second 5 orders were scheduled in the second batch, so they took twice as long. They took 240 milliseconds to complete. And then the 11th toy order took 360 milliseconds to complete. It had to wait. It could only be started until the previous 10 orders were completed in the groups of 5 plus 5 threads each. So if we compute this, the average time to complete an order for the boss workers model is 196 milliseconds. If we take a look at the pipeline model, the first order took 120 milliseconds to complete. 6 pipeline stages times 20 milliseconds. The next one was already in the pipeline, and once the first order completed, it had to finish the last stage of the pipeline, so its completion time will be 20 milliseconds longer, so 140 milliseconds. The one that came after that, another 20 milliseconds longer for 160, and so on until the very last order, which will take 320 milliseconds. So the average completion time for the pipeline model is 220 milliseconds. So basically, what this shows us is that if we consider execution time, if that's what's important, then we should pick, for this particular configuration, for 11 toy orders and 6 workers, then we should pick the pipeline model. It's better. It leads to shorter execution time. However, if what we care for is average time to complete the order, because that's what makes our customers happy, then the boss worker model is better. Its average completion time is 196 milliseconds compared to 220 for the exact same workload, 11 toy orders, and the exact same number of workers working in the toy shop. If you slightly modify this problem where you look at a situation with different number of workers or different number of orders, then you may end up coming up with completely different answers and drawing different conclusions as to which one of these models is better. Now, the important thing is, though, that when we look at a specific configuration, if we are the toy shop manager and it's concerned with completing as many orders as possible in a fixed amount of time, then maybe we'll choose under these circumstances the pipeline model because it gives us shorter completion time. However, if we're the customers of that toy store, then we probably would prefer if this was the model that the toy shop implemented because the orders will be completed in shorter amount of time. Important conclusion of this is that when we're comparing 2 different implementations of a particular problem or 2 different solution design points, then it's very important to think about what are the metrics that are used to evaluate those different solutions, those different implementations. Who cares about them?